Hello everyone, welcome back. In this video, I will cover the transaction verification mechanism used in Solana, which actually makes Solana faster. So it is nothing but the proof of history concept, which is like quite different from proof of history and proof of work. So proof of history is a concept which actually make transaction verification faster in Solana. So proof of history is being implemented using a function called as verifiable delay function. I'll talk more about what is VDF, and using that VDF, the validators solve these VDF function continuously to find out the actual output. If you see in the next slide, this is what VDF is. It is actually a recursive function where you have an input and it will produce an output. And output will be in the form of 256-bit long output. So let's say, for example, here I'm passing out some data. So this VDF function will generate some hash code, which is like 256-bit long. And then this hash will become an input to this particular function. And that is why we are calling it as recursive, because we are doing a recursive call to this function. And apart from this hash, we will also pass some transaction data, and then it will create the next hash value. And likewise for this particular thing, here we are passing this hash as an input along with the other transaction data. So if you see here, right, so here we have an input can be anything. It can be a random string or a transaction value. It will produce some hash 1. Then hash 1 will be an input along with some data or time also. Then it will generate hash 2. Then hash 2 will become an input and it will generate the hash 3. So it is about VDF. So now the question is like how the transaction will be decided. The basically the sequence of the transaction, like which transaction will go first, second, and then third. So in Solana we have a native clock that we call as crypto clock. So using what actually crypto clock do, it actually assign a timestamp to every network transaction. Like whenever there is a transaction happening on Solana, so this cryptographic clock will actually put a timestamp on that transaction, and using that timestamp only, the validators or the leaders will decide like the sequence of the transaction. So if you see here, it's a very practical example or the real world example where we have a leader node and also we have verifier or validator node. So let's say, for example, here in this case we have three transactions occurred. So what leader will do, it will actually run those three transactions on VDF, and it will generate the hash, the final hash. Okay, and let's the final hash, the third hash has a value, and that value is nothing but the state. Okay, after processing that, what it will do, it will actually pass those three transactions to the different validator, and then validator will also run the VDF on those transactions, and they will also generate the hash value. So if this hash value for validator 1 is matching with the hash value of the leader, then it will verify the block. Likewise for other validator. So here you notice, right? Here we don't need to wait much, or like here leader is not waiting for validator to confirm, or validate one validator is not waiting for the another one, because there is no dependency at all. There, like, because it is having a native clock, so even for time wise, it will like remain same like on every node. It does not depend like whether it is in Asia or Europe or USA. Everywhere this Solana clock, this native clock will have the same timestamp value. So that makes it a very unique way. Means there is no drift or any gap available in the time, although the nodes are residing in different zone. And this is how the proof of history concept work in Solana. I hope you will like this video and you have understood the proof of history concept very well. So, so we'll catch up in the next video. Thank you. Bye. Thanks.